Hello guys, welcome to Inside Electronics. So in today's episode is going to be a follow-up of my Exploded Things series. Things exploded during the power surge. Let me just zoom a little bit. Yeah, that should be fine. So in today's episode, let's take a look at an exploded LED bulb. Now this one is made by a company called Ormit, and it is a 3 watt high power LED bulb. And this one also exploded due to that power surge. And before opening it up, actually this thing, I think this I put this bulb like a month ago, and I still kept the cover for some reasons. But it came useful because now I can show you how it looks like when I bought this thing brand new. So let's take a look at the features of this thing. I'm not going to read through any of that, but this one is interesting. Instant start, 0 to 100 in 0 seconds. That's really super high fast. Let's open it and see what is wrong with this bulb. So right away you can see something inside. No, so there is no obvious signs of any charring or anything inside, and there is enough rust up here. Anyways, let's open it and see what's inside has gone wrong. Okay, that you can clearly see a bulb that is black in color. See that clearly indicates that this chip is gone, and probably that is because of the power surge, I guess. And I'm seeing a lot of things underneath, so let's take the circuit board apart. Let's push that. Oops, I don't want to destroy this thing up. If I can service it full one way or another, I need to keep the board. Oh, that was simple. And I can clearly see, oh, that didn't survive at all. See that is not good. That certainly is not good. And okay, the electrolytic capacitor is, can you actually imagine a capacitor over there by any sort? Let's take a look at the capacitor that is stuck inside and see what it is actually rated for. There it is. That little capacitor is not vented. Obviously is not no longer needed. Okay, right there, it's a dead giveaway what caused this thing. It's a 47 microfarad 50 volts capacitor. See, it's a 50 volts capacitor. Have you watched my previous video about my charger? It used a 400 volts capacitor, and this thing didn't even had a chance. This thing is only 50 volts, and that's a dead giveaway of what happened. The explosion, because of the extreme high voltage, this bulb popped, and that actually tells me that all these bulbs are in series. 1 2 3 4, it's actually 6 bulbs, and they are all in series. And this single bulb, or there may be other bulbs, but I don't know, I think this one is also blown. This bulb, it opens, and because it's all series, this bulb opens, the entire circuit voltage will raise to the main voltage. And right now usually it should have been around 220 volts, but in this condition, because of the bulb failure and the voltage that is coming into the bulb is 400 volts. And imagine that this thing rectifies it and stores it in this capacitor. Normally in under 230 volts operation, when you rectify it and store it on a capacitor, the voltage will be around 350 volts. That is when the input is on 230 volts. Okay, so imagine what would have been the voltage inside this, across this capacitor, when the input is around 400 volts. This thing doesn't even stand a chance. And this is the reason why you always need to use a high voltage rated capacitors in things like that. You can clearly see there is nothing, that is completely demolished. See, I don't even want to touch that. See that is the base. That's the base of a capacitor right there, and this entire thing. And I'm using this opportunity to show you guys what is inside an electrolytic capacitor also. It looks like some grandma's hair. Not really, but you know. And this is a series dropping capacitor, and looks like the capacitor is rated for, that capacitor is rated for 400 volts anyways, but still it looks that capacitor has survived. I don't know whether it has a short circuit or anything, and looks like most of the other components are also survived except this. Yeah, that is probably obvious because this entire thing is in series, and opening one little path over there will rescue every other LEDs inside the circuit. But that is really horrible. Let's just test that LED right there. Let's see if my theory is correct. I'm using a multimeter to actually check the bulbs that are like that. So I'm going to attach this side to the positive, and being a diode, this thing will actually emit some light if it's a good thing. So I'm going to plug this to there. I hope that is connected, and attach the negative to the negative, and nope, that is not going. So let me test it with the other LED and see if that thing works. That thing is also not working. No, the beeper is okay. So I'm thinking a couple of other LEDs is also bad, or should I check it the other way also? I should, probably, right? Nope, I'm thinking they're also bad. Anyways, nope, they're not working. And there is another reason I'm saying it is not working. It's because I know these are 3-volt LEDs and it will not light up in much lower voltage, but it was showing nothing on the meter also. So that is the reason why I'm telling that is bad. But I can probably repair this thing by replacing the capacitor and short circuiting this LED. But anyways, that will be a video for another day. I will probably try to repair this and I will make a video about this one. But that actually will give you how bad it is to use an underrated capacitor on a mains rated power supply. So always if you are designing something that is mains operated, do not use cheap capacitor like these ones. Always use high voltage capacitors. Anyways, thanks for watching. See you in another video.